Yes, we do. Great. We are doing significance tests now with sample data. Last units, we did significance tests, only significance tests, but we did it with proportions. Last unit, we had proportions for percentages. This unit, we will be given averages of sample data, and it will be in units that are not percentages. This is the notes of the worksheet. Last unit, we calculated the standard deviation so that we could find a z-score. We used the standard deviation of the square root of p times 1 minus p all over n, and we found that the z-score was x minus my claim over my standard deviation. This unit, the standard deviation is just going to either be given to you, or you can use one variable statistics to find it, because it's going to be of sample data. So you'd find the sample standard deviation. You would take that standard deviation and divide it by the square root of n, and that would be the standard deviation that you would use. Instead of finding a z-score, we will find a t-score. A t-score is just like a z-score, only it's going to be using a t-curve instead of a z-curve. But notice, it's still going to be my x-bar minus my mu divided my standard deviation, only your standard deviation will be the sample standard deviation divided by the square root of n.
Will be that's the S of x, right?
Yes, S sub x, the sample standard deviation of my sample means. Okay? Everything else is going to be the same. We are going to end up finding a p-value. We will compare the p-value to my significance level. Everything that we did last unit is going to be the same. The only thing that's different is that we're going to find a t-value, well, a t-score rather than a z-score. Okay, so quickly plugging this in. It's going to be approximately normal distribution with x bar equal to mu and the sample standard deviation of s over root n. Assuming the null hypothesis is true, the p-value is the probability of something that extreme would occur. Probability. You can do the significance tests using your calculator. You can also use these formulas. This is how you'd find the t-score. Making a conclusion, we would compare a p-value to a significance level. Typically, it's 0.05. We're going to reject our null hypothesis, our claim, if our p-value is smaller, which means it's further away from my claim, which means my claim can't be true if I found this sample data that is very far away. I'm not going to reject if your p-value is greater. That means our sample data is close to my claim could be true. Here is a first example. A company claims that a mean weight per apple they ship is 120 grams. Notice it's not a percentage, it's just a data point. Okay? It is the claim though. The claim is that the weight per apple is 120 grams with a standard deviation of 12. Your null hypothesis is that claim, that the mean apple weight is 120. Go ahead and include, you don't think that's true. Since you don't think that's true, and you don't care which way it is, whether it's too low or too high, you will say the alternative hypothesis is that we don't think that the mean weight is 120 grams. Now, we should remember when we have do not equals to, what do we have to do for our p-value? Multiply by 2. So immediately you should be thinking multiply by 2 for the p-value. Now, what's different about this type of significance test from the ones from last unit is that there's not that many calculations that you have to do. You are given the mean weight of your sample. Your X bar is 122.5. You are given your sample standard deviation, or the standard deviation of what you think, 12. So your standard deviation, S, is going to be 12 divided by the square root of our sample size. Our sample size was 49. With this, you can find your t-value, and then you can find your p-value from that t-value. What is 12 divided by the square root of 49, first of all? Yes, that's the sample. 1.714, ... Okay, now that we have that information, we can find our t-value. Our t-value would be my X bar minus my claim divided by this standard deviation given the sample and given the sample standard deviation. What do we get? .458 around. That is your t-value. We can now find our p-value. Now we use normal CDF from this to 10. We're not going to use normal CDF anymore. We're going to use TCDF. TCDF. Go to second dister. We will do TCDF. Again, we will go from this to the high point, which we'll say is 10. If this was negative, we would go from negative 10 to that value. So I do from 1.458 to 10. But since it's a T curve, we need to know the degrees of freedom. We need to know how steep the T distribution is. I need the degrees of freedom as my last value here. The sample size is 49. The degrees of freedom is 48. This would be your low, 10 would be your high, DF would be 48. You get 0.075 around. This is a p-value even though it's a TCDF. It's a probability value. It's a probability that something like this would occur if this was true. Now we multiply that by 2 since we have the does not equals to. And we get 0.1513 or something. This is our p-value. Okay, we compare that p-value to my significance level. This is greater than my significance level of 0.05. What does that tell us? Should I reject this claim that our mean apple weight is 120 grams, or should I not reject it? I'm not going to reject is exactly correct. This is not far enough away from this on a standard deviation basis for me to reject this claim. Do not reject. That this is that. Questions? Ms. Rios.
For the TCS, so the low would be the 1.5. What is a 1.45? The upper is 10, and then what is this?
This is the degrees of freedom. This is n minus 1. Your sample size minus 1 is the degrees of freedom, which is used to tell us how steep our T curve is.
I thought it was I got 1. Is that? Oh, because I don't know how to. Okay.
So go back in here and plug in 1.458. Okay, next problem. go to number 2. The new formula for the propellant of missiles is being tested to determine if it's superior to the current formula. From past experience, the mean distance traveled has been 340 miles. This is a claim. We think that the distance traveled for this propellant is 340 miles. 12 missiles from the new propellant are fired in the Pacific Ocean and their distance are measured. The data is given below. Is the new formula superior than the current one? Well, my alternative hypothesis is that hopefully it's going to be greater than this 340. Now I'm going to show you the easy way you could do this, and you could have done the last one with your calculator as well. Go to stat test t-test. If you go to stat test t-test and you go over to stat test t-test, and you go over to stats, we could have typed everything in from the last problem and we would have gotten the correct answer. 120 grams, this is not correct, this is different, but n of 10, boom, you would calculate, you would find your p-value. We could have done z-test, yes, last unit. But now we're going to use data exactly right, Mr. Funk. We will use data. We will go into stat edit, and we will type in all of our data. Then we'll make sure we have the correct null hypothesis, is that the claim was that it's 340. We'll use the list one. We'll make sure we calculate the correct alternative hypothesis, which is that it's going to be bigger than that value. Press calculate, find your p-value, compare it to your significance level. I'm going to do that right now, and I'm recording the video right now. If you want to see the answer, you can look online. But it's really the same thing as last unit, just with a little bit minor differences in the calculations. $375, $376, $304, $368, $329, $372, $347, $342, $391, $400. I want to see 7 calculators up there. I'm upset. I want to see 8 calculators, really. All right. I got it. Stat, test, t-test. Boom, 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 boom. Here we go. We get a p-value of 0.03. We get a t-value of 1.94. This is less than the significance level of 0.05, which we use, so we will reject this. We will favor that our new propellant works better than the old propellant. It is likely or unlikely that 12 missiles selected would travel at least 356 miles if they travel 340 miles on average. It's unlikely. We just found that. The likelihood is a 3.8% likelihood. Okay? So that's really how you do it. Good luck on your homework.